Very warm welcome to all my dear friends and students. A very good morning, good afternoon, good evening to all of you. I am Raghunandan Sengupta from the IME department IIT Kanpur, and this is the DADM 1, which is the data analysis and decision making 1 course under the NPTEL MOOC series. This is a course for 30 hours, which is 12 weeks, and each week, as you know, and there are 5 classes, each being for half an hour. So, we will start the 11th class, which is basically we are going to start the third week first class, because 5, 5, 10 are already over. So, if you remember that we were discussing about the normal distributions, and I did say that what does the small phi capital phi mean, the if x is normally distributed, how it can be converted into a standard normal deviate using simple Jacobian transformation. And for the case where x has a mean value of mu x and variance as sigma square, which two are the parameters for the normal distribution, it can be converted into a standard normal with z, where the mean value of z is 0 and the variance is 1. Now, consider the normal distribution, and if you remember also, I had in the last slides of the 10th class, I had written this, which I will write again. For let me use the red color, so it will be clearly visible in this slide. So, what we analyzed was the probability of A being less than equal to x being less than equal to b. We have to find this. So, what technically we do is that we convert x into z. So, when you convert that, you use the formula z is equal to x minus mu. So, this mu is basically the mean value of x by sigma. Correspondingly, the a value also gets converted, b also value also gets converted. So, I am going to write that, erase that, considering there is no space, I will erase it and write it accordingly. So, probability a now becomes a minus mu by sigma less than equal to z. So, this had already been converted, less than equal to b minus mu by sigma. So, this would be z 1 a realized value, this would be z 2 a realized value. So, technically this z 1 is the transformed value for a, and this z 2 is the transformed value of b. Now, as you know, we did mention that in the limiting case as a tends to 0, the probability or the value, actually this value basically becomes a tends to minus infinity, my apologies, minus infinity. So, that means it is tending towards the extreme left hand side in this case. So, obviously, this will vanish. In the case when b is tending to plus infinity, this will actually become plus infinity. So, that the corresponding probability will be 1. That means, this is shifting to the right and this is shifting to the left. So, we can find out the values. So, this being a standard normal deviate being z, the value onto the right hand side, if it is plus z, the value on the left side would be minus z, because they are equally dispersed, symmetric. So, now we want to find out the standard normal deviate and the corresponding CDF values. CDF is the cumulative distribution values, based on that we can find out the probability. So, concentrate on the diagram on the normal distribution on the left hand side and corresponding standard normal probabilities which are given on the right hand table. So, now what you do, this pink area actually means this is the overall CDF value for finding out the summation of all the probabilities starting from 0 to a value of 1.56. So, if that is the value, how do we find out? Now, and obviously, it would also mean that if you move on to the left, that means this side, then the corresponding CDF value or the sum of the probabilities from moving from 0 to minus 1.56, or in another way of moving from minus 1.56 to 0, the overall area would be exactly equal to the pink area which is shown. Now, let us refer to the tables. So, the standard normal tables has Z values along. So, I am just hovering my pen over that Z values starting from 0, 0.1, 0.2 till 3.0, and the decimal places, which means that it is 0.00, that is second decimal, 0.0102 till the last value is 0.09. So, if I want to have a value of 0.11, then the corresponding Z value would be not the Z value. So, I am saying the corresponding cumulative values would be this, which technically means that if I find out the whole area starting from 0 to 0.11, the overall cumulative value is 0.0438. Now, let us come back again to this diagram, which is shown in pink, the shaded region, and try to find out that what is the corresponding probability distribution sum, that means the CDF value. So, the value is 1.56. So, let us go to 1.5 first. So, this is 1.5, this is 1.56. So, the corresponding value which you have here is 0.4406, that means the total area of this pink shaded region is given as 0.4406. So, the corresponding value, if I go on to the left hand side, it is from minus 1.56 to 0, again the overall area here also would be 0.4406. So, standard normal distribution has a mean value of 0, variance of 1 is given by the equation f of z 1 by square root of 2 pi, because sigma is 1. So, obviously, it would not be there, and in the numerator what you had in the actual normal distribution is e to the power minus in the bracket x minus mu whole square by 2 sigma square. So, mu is 1. So, obviously, in that case mu is 0. So, obviously, in that case it will be z square, and in the denominator you had basically 2 sigma square. So, sigma is 1. So, it will be 2. The area within an interval a b is given by this equation. So, you want to basically find out the overall area a b. This area is given by the integral from a to b 1 by 2 pi e to the power minus z square by 2 dz, which is not integrable algebraically. So, hence many of the cases we use Taylor series expansion of the above in order to basically do the speed calculation. So, this is the Taylor series expansion based on which we will do. So, this half basically is coming because it is on the left hand side you have already covered from minus infinity to 0, which is 0.5. Now, in the standard normal distribution, if you move plus 1 sigma minus 1 sigma to the right and the left respectively, the overall point at which the graph changes. Now, what do I mean by graph changing is that dy dx of that point is changing. So, if I continue finding out the slope from this point at the mean or the mode or the median, the dy dx is 0, that means the max, and obviously, the second derivative would be negative, because that is why you find out the maximum value. Now, there are 2 points at which the rate of change of the function changes from positive to negative or negative to positive. That means, the second derivative is also 0, that those points are the point of inflection. So, the point of inflection for the normal distributions are plus sigma on to the right and plus sigma on to the left. So, at these points, which are the black one, which I am now highlighting with red. So, at this point the rate of the change of the function changes from positive negative, negative to positive. So, let us consider a very simple example. In an examination, 20% of the student failed, that is obtained a score which is less than or equal to 40 marks out of 100, and 10% of the student obtained a grade A, that is scores of 70 marks or above. Assuming normal distribution of the marks, find the mean and the standard deviation or the variance of the distribution. So, we are considering the marks of the students are normally distributed. So, when we consider probabilities of less than 40, it is 0.2. So, if I consider x has a mean value of mu and a standard deviation sigma square. So, obviously, I do this transformation. So, this becomes z, corresponding value is 40 minus mu divided by sigma square. So, this is z and this is small z 1. So, in that case what I am doing technically, I am trying to find out the integration of all the values starting from minus infinity to that value of z which corresponds to 40. So, this is the value which I find out, and that is given as when I that is given as 0.2. So, if I basically find out 0.2, because if you remember till the mean value is 0.5. So, obviously, the area of till the value where you calculate the value of 0.2 would be on to the left. So, hence the negative value. So, it comes out to be minus 0.84. For the case when x is greater than 70, so that means on the right hand side the value is given as 0.1. So, in this case greater than 70 on to the right is 0.1. So, again we transform, this becomes z, this becomes z2. So, in that case if it is 0.1, which means the overall area, if I add up here, let me use a different color, it will be easy. So, the area on to the left, consider this is z2, would be 1 minus 0.1, which is equal to 0.9. So, if it is 0.9, so hence again from the table I can find out z2. So, I found out z1 and z2. So, there are two equations, I find out z1 and z2. Now, correspondingly we know z is equal to x minus mu by sigma, put z1, put z2, two equations, two unknowns, solve them. So, z1 comes out to be minus 0.84 and z2 comes out to be plus 0.9, because you are moving on to the right. So, this is the mean value which is 0. So, this is already, this whole area is till 0 is 0.5. So, you have to add 0.4. So, 0.4 basically makes up, such is the case you can find out the z1 and z2 value. So, based on that you find out the values of z1 and z2, and once you find out z1 and z2 you solve and find out that mu value is 50.12 and the variance. So, square root of that gives me 17.64. Consider if Professor Rampal's mathematics examination. So, this is an example, 20% of the students failed, the same thing. So, I am putting into different words, obtained a score which is less than or equal to 40, 10% obtains a grade A score of 70 and above, assuming normal distribution, you solve it. It is the same thing. So, okay, only one error. So, there the value is 1 point plus 1.28, it is 0, not 0.9, 0.9 was basically the overall probability. So, z1 is minus 0.84, z2 is plus 1.28, based on that you find out mu and sigma, which is 51, approx, I am giving the approx value, and it is 14. So, this is the solved for that case. You can use the standard normal deviate table. Only remember, the standard normal deviate table is given on to the, if it is only given for the half of the distribution, you can easily use that for the full distribution. In many of the cases, the actual integration values based on which the values are given are starting from a negative value to a positive value, such that you have to basically divide it by 2 to find out the overall area. What I mean is this. So, this is 0. So, it starts from negative value to positive value, and the tables are values are given accordingly. So, if it is given as, say for example, minus 3 to plus 3, the overall area is given here somewhere in the table, you divide by 2, find out the area for the integration from minus 3 to 0 or from 0 to 3, whatever you look. So, this 3 minus 3 and plus 3 I am taking as an example. So, it can be anything. So, this is an assignment, again not to be solved as an assignment in the examination, just to be tried by you. Dr. Satish Kashyap finds that his patient's height are normally distributed with mean 165 and standard deviation of 20. What is the probability of a patient height being between 160 and 170? So, the mean value is given 165. So, I want to find out, let me use the red color. So, I want to find out this So, what I do, I transform this into z. So, it will be 160 minus 165, standard deviation 20 less than equal to. So, it becomes z, because I have now transformed x by, so this is equal to z. No, sorry, this is capital Z. So, these are values, realized values of small z. 170 minus 165 by 20. So, this becomes, so this value first is minus 5 by 20, this is minus 1/4, this becomes 5 by 20, this is basically 1/4. So, point minus to 0.25 plus to 0.25. So, you have the distribution from minus 0.25 to plus 0.25, you go and try to find out the areas accordingly. So, normal approximation to binomial distribution, let x b and p. So, binomial being parameters p and n, where n is a large and p is small, then the distribution can be approximated by the normal distribution given, where the mean value would now be the mean value of the binomial distribution, which is n n to p, and the variance which is for the binomial case is n p q, will be utilized as the variance for the normal distribution, such that mean value and the variance for the binomial distribution become the mean value and the variance for the normal distribution. De Moivre's Laplace limit theorem. So, in this case, so this is what I just discussed for the binomial one. So, probability of x being between a and b both inclusive. So, what I am trying to basically do is that try to convert a discrete binomial distribution to the normal case, which is continuous. That is the essence, and how we replace that, that is the main value, main crux. Now, in that case, when we so in that case when we convert x into z, it will be x minus mu divided by sigma. So, what is mu? Mu is the corresponding mean value of the binomial distribution, which is n into p, and the variance is n p q. So, the square root of that will give me the standard deviation. So, it will be capital sigma b minus n p divided by square root of n p q, and for the case when we find out for the b case, it will be, because b is on to the right hand side. So, I have to add up much more values to get to that. So, it will be b minus n p again divided by square root of n p q. So, those formulas remain the same, only that we should remember the addition, that means all the probabilities I add up for b is from minus infinity to b, and for a it is minus infinity to this point. In between that area will give me the overall area which I want to find out. If b tends to plus infinity, then obviously the capital phi with b becomes 1. If a tends to 0, so obviously you have to find out the corresponding value. So, if 8, oh sorry, my mistake, this is a. So, if a tends to 0, so obviously you add up all the values from minus infinity to b. So, this is capital phi as written. We will consider two inequalities. So, one will be this, consider z is a non-negative random variable. So, it does not mention anything about the variance, it only mentions that z is not the standard normal deviation, remember. So, z is a non-negative random variable such that the expected value exists, it does not mention anything about the variance. Then for every positive t, we will have the probability of z being greater than a number t is less than equal to the expected value divided by t. So, what we are trying to do, we are trying to find out some bound, that means corresponding to a distribution z which is non-negative, first moment exists, we are considering that the bound for that particular random variable to be greater than some fixed value t. T is a variable, but it can change, but we know beforehand, is less than equal to the expected value. So, expected value is the basically center of gravity of the distribution, whatever the distribution is. So, consider the distribution is and the center of gravity is this. So, center of gravity divided by t. So, what we are trying to do is that the probabilities multiplied by the distance from the for the case. So, it is like this, let me consider t values here. So, the probability of the z value being greater than t multiplied by t. So, that means t is the distance on the x axis, that would be given by the expected value. So, what we try to basically portray is that how number one we can portray the maximum value or the limits of the probability, and also we give a different expression for the expected value in terms of the probability and the distance function. Distance I am just giving a nomenclature, it does not actually mean distance, it is basically a positive numbers. In the case of Chebyshev's inequality, let x be a random variable, it does not mention anything whether it is a positive or negative, remember that. The first moment exists. So, mu x is nothing to do with the normal distribution, it is just a symbol being used for the mean value. Variance is sigma square, again nothing to do with the standard normal or the normal distribution. Then for every positive t, we have a bound. So, x minus mu mod of that is basically the fluctuation of x over the mean and under the mean. So, that value would be greater than the value multiplied any t value multiplied by the standard deviation, and that probability will be always less than equal to 1 by t square. So, if you basically shrink in, that means make that overall mod value as small as possible, then obviously the corresponding probabilities would change. So, remember that what we have actually, let me use the, this is the mean value, this is the mod plus and minus. So, I am trying to find out the overall probability that this is greater than t sigma. So, if t is 1, so in that case probability value being greater than the standard deviation is less than or equal to 1. So, obviously, here also you are trying to put a bound based on which you will basically try to find out the probability between the limits. Limits means the mod value. So, consider t is 2, in that case the probability of that bound being greater than or equal to 2 sigma is less than half. So, as you basically expand or contract the bounds, the corresponding maximum or so called minimum values for the probabilities are given by the value t. T is also again not random, it is you can change, but it is a known value. So, Bernoulli's theorem states that if x n, so now x n is basically the number of successes which you have. So, this n technically means the number of samples. If x n be the number of successes in n number of Bernoulli trials, each with success probability p, and an unsuccessful probability being 1 minus p or q, then for arbitrary positive epsilon. So, epsilon would basically depend on the n value. We have as n tends to infinity, that means as n tends to increases, then the corresponding difference between the actual probability and the relative frequency in the long run starts decreasing and exactly equals less than equal to some epsilon value. The epsilon value can be very small, it can be 10 to the power minus 13, 10 to the power minus 14, 10 to the power minus 36, whatever. It becomes smaller and smaller, tends towards 0, such that that probability tends towards 1 as n tends to infinity. So, let me give you an example. We know if you toss a coin, probability of head and tail for a unbiased coin, not the Cholet coin which we see where both the faces are head, an unbiased coin has the probability of head as half, tail as half. Now, do think of this in this way, if you toss the coin, so the relative frequencies of the heads would be number of heads divided by the number of tosses you are doing. Relative frequency of tail would be number of tails divided by the number of tosses. Keep increasing the number of tosses. So, you will get relative frequency of the head also and the tail also. In the long run, as n increases, then the difference between the relative frequency of the head minus 0.5 would tend towards, the difference would tend towards 0 with probability 1. Similarly, the relative frequency of the tail number of tail divided by number of tosses minus the actual probabilities is 0.5, that will tend towards 0 with probability 1. So, that is the essence. So, it can be thought out for any of the examples and it can be assumed accordingly. So, we will consider the central limit theorem and it will be utilized time and again. So, let x 1 to x n be independent and identically distributed IIDs random variables. So, what you have is that you are picking up any observation from any distribution and you pick up the first one, keep it. Do such n number of picking 1, 2, 3, 4 till n. Do not worry about with replacement or without replacement, because the population is so large. Now, note down the values, again put them either in the box or you do not, because it is infinite population. Again pick up, put them on the table from x 1 to x n, note them down, either replace them or throw them away. Continue doing it and do it infinite number of times. So, what will come out is that if you know the distribution of that population, then it is considered as mean mu. Now, consider each of the picking which you are doing, groups of picking you are doing, and only concentrated on the first picking. Technically, in the long run, that place can be filled up by any one of those actual values which are there in the box. If that is true, then if I want to find out the probability of the first picking, it is intuitively exactly equal to mean. Similarly, if I concentrate on the second one, do infinite such pickings, only concentrate on the second one, the actual probability of the second picking is also mean value is also mu. So, in the long run, if you continue infinite, expected value of xi is mu. Similarly, the variances of xi is also sigma square, because you are doing infinite one. So, in that case, when I pick up the sum, so sum is basically x 1 till x n, and I want to find out the mean of that sum. So, if I consider the sum, it is x 1 plus x 2 till x n, and if I want to find out the expected value of the sum, it will be expected value of x 1 plus expected value of x 2 dot dot till expected value x n, because there are IIDs, because there are independent identically distributed, because there are infinite number of such observations. Now, the expected value for each picking is mu. So, hence the expected value of S would be mu plus mu plus mu, how many times? N number of times. So, the expected value S becomes n into mu. Now, I want to find out the expected value of S, which is the sum. So, what I do? I have found out the expected value of S, which is n into mu. The average value of actually for x 1 to x n is S by n. So, the expected value is n into mu divided by n. So, it again becomes mu. That means, the expected value of the sample is exactly equal to the population value, which is mu. Now, if I consider for the case of the variance, now remember for the variance, I will come to that later on more discussion. The variances are also, the pickings are also IIDs. So, the covariances, the concept which I am using for the first time, I will come to that later on, would not exist. So, what you will have is basically only the principal diagonal in an n by n matrix. So, you will basically add up sigma square n number of times, but the actual formula for the variance is a square. So, n square would come when you try to find out the mean value, would n square would come in the denominator. Hence, the actual value of the variance for the that average would be sigma square n into sigma square by n square, which will become sigma square by n. And finally, if I put the actual distribution of x n, which is the mean value. So, it will, as I mentioned, the mean value would be mu, the variance will be sigma square by n. So, when I convert that mean value considering a normal distribution, it will be what? We know it is x minus sigma, which is the average value of x divided by standard deviation x. So, in this case, sigma remains sigma and the standard deviation is what? The variance was sigma square by n. So, the standard deviation would be sigma divided by square root n. So, that would basically be a standard normal deviate as given, because we know the expected value of x n, this the bar is the average, is mu, and the variance is given by sigma square by n. So, finding of the square root would give you the corresponding thing. I will come to that those results later on in more details. So, with this I will close the 11th class and wish you all the best, and thank you very much for your attention. Have a nice day.